because casting pile, you need to wait until the 28 days to test the what they call the achieve of the strength lah. Okay, so compare a precast pile, you just install, or you just uh, reinforce your punya soil or your foundation. Okay, so it's very fast compared to using a cast situ pile. Okay, but if you compare in terms of the strength within the cast in situ and precast pile normally is already fixed in terms of the strength. Okay, but cast in situ you can develop, okay, by using additional admixture to develop more extra, for example, another strength of for your concrete. Okay, you can put some admixture, okay, to increase the pile strength. Okay. Okay, for your information, ball pile is the ultimate, okay, the highest design for the foundation. Okay, if you look at uh, what is the strongest design in the foundation is the ball pile, which is normally we cast in situ. Okay. All right. Okay, steel pile. Steel pile also we can apply. For example, if your area located is hilly area, okay, the best thing is the for convenience of logistic, you use a steel pile because it's very easy to transport. Yeah, compare you use a concrete pile, you need a machine to mixture. Okay, if you use a precast, so you need a big lorry. But for a steel pile, okay, the the size will be more small compared to concrete pile, but can achieve a approximate strength. Okay, between the both pile. For example, let's say uh, the pile strength for concrete pile is 250. Okay, but the diameter is quite around maybe around half meters. Okay, but if you use a steel pile, maybe the size will be more 3 times smaller uh, compared to precast pile. Yeah, that's the advantage of if you apply a steel pile. Okay, but the disadvantage is due to corrosion lah. So you have to protect with a proper coating. Yeah. Okay, this is the example of steel pile. Okay. Okay, there is another also shape for steel pile that you can apply. For example, like a circular, or we call as a pipe pile. Okay. All right. Okay, when we design pile, of course, we will look at on the capacity of the pile. So different type of pile will carry a different capacity of pile. Okay, for example, like timber, the capacity will be more lower compared to a concrete and steel pile. Okay, it depend you if you are as engineer, you will look at on the first, of course, the cost. Okay, because the when you have a certain project, they will have a ceiling price for the project, so you have to fit in your design with the selling price of the project. So one of it, you have to optimize the design of your file. Okay. So for example, like your building, okay, your project is more on small structure, okay, one double story, apa ni, one story structure, okay, and then your area is covered by low bearing capacity of soil, okay, then you have to use a pile foundation lah for design of your foundation. So you have some choices. Either you want to apply timber pile or steel pile or concrete pile. So it's depending. First, you have to consider in terms of the cost. Okay, based on your ceiling project. So if you can optimize, for example, you want to use a timber, okay, because the timber is more cheaper than compared to steel or concrete pile. So you and then you have to check in terms of your design, either is a fit in your design or not. Okay, and then you compare with the concrete pile in terms of the price. Maybe the price will be more higher, and then but it's more stronger compared to use a timber. But in terms the if you could compare in terms of the durability of the strength, timber still achieve the strength, the required strength, okay, the required capacity, okay, but the concrete and the steel is more higher, okay. So you will play with the certain factors to optimize your design. So normally in real project, we will come out with a three conceptual design with different concept and different materials. Okay, right. Okay, so to calculate the ultimate capacity of pile, the basic theory and the basic question is the friction you pass with the capacity at the tip of the piles. Okay. Okay. Typical of pile foundation design. So normally for pile, we can design either using a floating pile or end bearing pile. So for the floating pile, normally it's depending on the screen friction uh, uh, along the surface of file. But for the end bearing, you have to do the socket, okay, at the bedrock of your hard layer. Okay. So normally for end bearing, we will allow around 3 meters, okay, socket, okay, to lock your pile, okay. So for example, if you can say you if you can see the building, okay, the building, some of the apron, the surrounding of soil is settled. So due to the high compressibility of soil, okay, but the building still uh, apa ni still no apa ni still wait ada gangguan sekejap, sorry ya, kejap ada emergency. Okay, sorry. Ada gangguan tadi. Okay, sampai mana sudah tadi? Okay, give you example. Okay, our building at FKJ lah. Okay, if you can see, the structure is still stand. There is no settlement on the structure of the building. But in terms of the apron, the surrounding of soil is going to settle. So do you what? Because the structure, the buildings is designed by and bearing pile. There is no effect due to settlements. Okay, but all the surrounding soil is settled. Okay, but let's say the building is designed under friction pile, the building will settle together with the surrounding of soil. Okay, there's the difference when you design end bearing and friction. Okay, pile. So of course, when you design using a friction, the cost will be more cheaper compared to end bearing pile. Okay, because the amount of pile will be reduced lah. So this is some of the example of illustration of mm, the pile foundation lah. Okay, support the structure. Yeah. Okay, on the top. Okay, in design the pile, you have you have to check two any two calculations lah. Two calculation. First, single file, and the second one is a group file. Okay, of course, all the design will be we consider as a group file lah. But in term of a single file design, you have to check another calculation uh, to avoid something like a failure, like punching shear, something like that. So you have to check the each of capacity of your file. Okay, all right. Okay, okay. In group file, like in design group file, normally it's depending on the spacing lah, spacing of your each file. Okay, the more close of your file, the more strongest you will obtain the capacity of your deep foundation. But in terms of cost, it's very high. So you have to optimize your design. Okay, and then also another factor play the important roles is in your design is the size of your file lah. Okay, that is the example of group file with arrangement of square pattern. Okay, when we design any kind of element of structure, for example, like slab, beam, so normally there is a factor of safety. Okay, normally for pile, we use between 2 or 3. Okay, for factor of safety. Okay. Okay. How you gonna determine the numbers on the spacing of the pile? So it's depend on your dead load from your structure. For example, let's say your dead load structures around 1000 kilonewton. Okay, and then you have a piling and a single pile have capacity is around 200. Okay, so you divide 1000 with 200, so the required numbers of pile will be 4 pile. This is the way how we identify the number of piling. Yeah, and then you can arrange in terms of the spacing. Yeah. All right. So this is another pile cap. Okay. And then pile cap also you can actually it's depending on your first number of your pile. For example, let's say you have only 3 pile. So you can arrange a trapezoidal shape, something like that. Okay. So it's depending on your number of piles, yeah, or pile cap. And also you can use a square pile cap juga lah. All right. Okay, this is the some of the how we gonna identify the size of our pile cap. Okay, you can use this theory, which is we call as the thrust theory. Okay, thrust theory, and then we identify from the axial force lah, which is from your dead load from your structure. Okay, so you can apply uh, this theory to identify which shape, which pattern of your pile cap suitable for your design for your pile. For example, like if you have only two number of pile, so you can use uh, only you can use rectangular pile cap lah. Okay, let's say you have a 3 pile, so you can apply uh, triangular patterns. Okay. Okay, this is another example for different shape of the piles. Okay, right. I think in your final exam, this equation will be given. Yeah, don't worry. So you just need to know how to identify the size of the length, and then the depth of the pile cap, and then the numbers of your piles required. Okay, so this is another design pile cap. So okay, right, right. Okay, this one is for the steel. Okay. All right. So this is the allowable load or allowable capacity of different typical of piles. Okay. As you can see, steel will be the highest capacity compared to precast and cast in situ concrete and woods. Okay. But it's depending on the size. Let's say the size of uh, concrete pile is 1 meter diameters. Okay, for concrete pile, you can use maybe 3 times smaller or 4 times smaller by using a circular or edge section by using a steel pile. There's the advantages of steel pile. You can save in terms of the space. You can save in terms of convenience of logistic. Okay, there's a few advantages lah. You apply a steel pile, but in terms of the price will be more higher. Okay. All right. So when we design friction, there is a coefficient you have to consider. Okay. For example, different type of materials will have a slight different of what they call is interface friction angles. Okay. They call it interface. Okay. So for example, concrete will have around 0.45 wood. We can consider similar with the steel, which is have a rusted surface, okay, which is 0.4. For the smooth steel is around 0.2. So this the it's very important. You have to identify your what they call first your available design, and then the second one is your what they call the maximum of your dead load. Okay, you will determine what is the best or the optimized design for your pile condition. Okay, when we design, of course, we will refer on uh, the typical of the failure. Okay, anything your design, for example, you want to design a beam, you have to refer based on the theory how it's failed and the failure, how you resist the failure. This is the way the theory how we start the design lah. Okay, in the file also is similar concept. So it's based on the mechanism of the failure. Okay, so for example here, so we have in pile condition, we have a punching failure, shear failure, and then we have another apa lagi ni, bulging now. Punching failure, shear failure. Another thing is shear failure, punching failure, and then apa lagi satu ni ya? Saya lupa. Hmm, punching failure, shear failure, tip failure. Okay, never mind. So normally we will refer on the punching and shear lah. For punching is you can refer on the A punya section ni lah, figure A, okay? No. For shear failure is based on this A punya figure, okay? Shear failure. And then for the punching is based on this C punya, okay? C punya punching failure, okay? And then with different theory and different researcher there, for example, for A is based on the Terzaghi, and then come another different researcher, which is Mayoff. They come out with the theory of B shape of the uh, mechanism of failure or shear failure. Okay, so there is some revolution of the mechanism of failure for piling. Yeah. All right. For Okay, this one for a floating pile. Yeah. So normally we will consider only skid resistant lah. So let's just say a different type of your pile. For example, wood pile atau timber pile. Okay, there you have to consider the smoothness of your surface of your pile, because it will contribute to the parameter like interface friction angles. Okay. Okay. So the lowest of your value of your interface interface friction angle will carry will affect the performance of the skin resistance of your piles. Okay. All right. So there's a three method. This one is patented by Mayovny. Alpha method is depending on the typical of the soils. Yeah. Alpha method. Uh, then you have beta method. All right. So for alpha method, they will have different equation lah. Yeah. Sorry, because this slide is from Dr. Habib. I think there is some like information lah in terms of the alpha and the beta. So normally for alpha and beta is based on the typical of the soil. So for alpha, you can apply for the like the cohesive soil, and then for the beta is normally for the non-cohesive. I think this slide is from Dr. Habib, so I just use it. But never mind, just for your itulah, yeah. I think there is some like information lah in this slide. All right. Okay, for the group file, like I said, okay, it's depending on your your maximum of your dead load lah. Okay. So for example, let's say you have 1000 kilonewton, okay, dead load. So you have to divide into uh, the available of your capacity single capacity of your pile. For example, let's say you have one pieces pile, so the capacity is 200. So you divide it. So the required uh, a number of file will be four numbers. Okay. Okay, this one is the code practice recommendation by the Norwegian. Okay. Okay, for me, I'm not really because I'm not really recommend by using a Norwegian code. Actually, you have to identify your, you have to test it, because we have a different uh, environment with the Norwegian. Okay, so for me, if you check in terms of the recommended for friction file, you have to test it and the uh, what it calls using a shear box test. Okay, so we have a different typical of soil and different moisture, okay, humidity with the Norwegian. So I'm not recommended to use this recommendation lah. Alright. Mm-mm. Thanks, invested. Okay, this one. Okay, this one is how we identify the what I call the the size and the spacing of your file. Yeah. Okay, n will be the number of your file. Okay, and then the d is the diameter, the spacing. Okay, the spacing, and then you have l. L should be the apa ni, the length of the file. Yeah. Okay, never mind. Somehow, okay, the slide. I think okay, never mind lah. Should be okay. Oh, there is a difference between the when we design. Okay, I just want to give you okay. When we design file in a different typical of soil, uh, you can you can use the theory by the by researcher apa ni Professor Mayoff lah. Okay, for cohesive soil, normally we apply the alpha method. Okay, for the sandy, normally we call it a beta method. Okay, it's depends on the you punya coefficient. Okay, coefficient normally for alpha we only have coefficient like NC. NC is referred to the cohesion. Okay, let's say you punya itu there is another coefficient. Okay, if you still remember how the Terzaghi equation, you have to times with the NC, NQ, something like that. That one is the number of factors for bearing capacity of soil. Yeah. Tapi dalam apa ni lecture Dr. Habib ni macam tidak berapa tersusun lah. Tapi never mind. If you have anything, you can ask me lah later. Alright. So we look at the example. So now the example, let's say you have a 360 kilonewton load. Okay. Okay. The soil is made from the clay. Okay, soil. So you have capacities around 115, 115, and then the bulk density is 18.1. Then the length, you have to determine the length. Okay, a square pre-stressed concrete is to be driven in the clay soil. Okay, the design capacity file is 360. Okay, first your design capacity of file is 360. Okay, you have to calculate the ultimate. So of course, when you say ultimate, you have to times with the factor of safety. So normally we will consider as two lah, two okay for the factor of safety. So let's say your soil uh, apa ni dominated with the pit soil, you have to times the factor of safety cover 3. Okay, it's depending on the condition of the soil. So factor of safety is the way we protect our design. Okay. right? And then you have the bearing capacity is around 100, 115. When you divide, you will obtain the C, the cohesion lah, okay, of the soil. Okay, so by using apa ni, alpha method, I think it's the alpha method because only the clay, the cohesive, yeah. So you have to times C with the this one is the apa ni, NC is represent the coefficient for cohesive soil. Okay, that's why I'm really confused with the Dr. Habib slide. Supposed to be there's a differential between the cohesive and non-cohesive design for pile. But never mind. Okay. So normally the basic the normal condition of the clay for NC value we take is a 9. Okay, 9. So you have to times with the NC value, so you will obtain the allowable capacity at the tip. Okay, so the ultimate, so you have to times with the area, so you can obtain the the ultimate, okay, the design load for at the tip section here. All right. So for the ultimate, normally we combine the friction and the tip. Okay. Of course, the file, how the file is enhance the load from the structure is through the first the skin restriction, skin resistant, and the second one is the tip size, means the bottom area, the bottom area of the pile. Okay. Okay, if you consider your design as a floating pile, so the ultimate you can minus with the capacity of the tip of your piles. Okay, so you can obtain the ultimate friction, uh, the ultimate floating pile capacity. Okay. All right. Oh, habis sudah. Uh, Never mind. I think you can request also from Dr. Habib lah. So how to use, how to identify different between the cohesive and non-cohesive pile, non-cohesive soil, and for non-cohesive. There is a different method when we design, okay, pile. Okay, a different formula, okay, and then different coefficient. I think in his slide doesn't appear, yeah, but never mind. So any question, class? Hello? Hello? Ada soalan nggak?
Question, doctor.
No questions.
No question.
No, doctor.
Okay, I think our class until here. If you have any question, okay, regarding the design, actually 2 years ago I teaching this subject lah. Okay, I see there is some information need to upgrade. Okay, especially on typical of the soil. Maybe Dr. Habib too busy because apa ni, before this he's a KP, so a lot of itulah dia punya apa ni work and heavy work lah. As a KP, you have to handle all the things regarding the program. Maybe dia tidak sempat lah to upgrade the slide. There is a few things, especially for the typical different types of the soil, the different formula design for the file. But never mind. Let's say you have something you want to ask about design different two type of soil, so you just let me know lah and text me. So I will try to guide you. Okay. So I think that's all for today. Thank you very much and have a nice day lah. Now this is our last class, so it means I already covered you until the foundation, foundation. Okay. So the rest you have to do it, especially for the exercises and theory at tutorials. Okay, the example you can do is your exercise lah. Okay, so thank you very much. Okay,
Thank you, Doctor.
all
Thank
right.
you, Doctor.